Hello, dear participants of International Scientific Conference of Communications, Information, Electronic and Energy Systems. I am Rustam Can Sadekov, independent researcher in Tashkent University of Information Technologies, named after Muhammad Al-Khwarizmi. I am participating to this conference with my article on theme on numerical method for modeling oil filtration problems in piecewise inhomogeneous porous medium. This presentation is about modeling of oil and gas fields. Oil and gas fields in natural conditions are rarely of homogeneous nature. Given the chaotic nature of changes in rock mass permeability within a single layer, its significant parts areas can be considered uniform in permeability. If significant in size, homogeneous zones regions are distinguished within the formation, the parameters of such macro-inhomogeneous formations significantly affect the characteristic of the filtration flows. The area of zonal inhomogeneity consists of the parts of different permeability within the same zone. The permeability is on average the same, but differs from the permeability of adjacent zones. The objectives from this article is about development of effective computational algorithms using mathematical and computer modeling methods of approximate analytical and numerical methods of filtering of liquids and gases in a non-homogeneous porous medium layer in the dissertation work and the creation of software for visual representation of numerical results in 2 and 3D graphs. This article consists of 4 parts. The first is mathematical model and the second is numerical simulation. The third is computational experiments and their visualization, and at last, conclusion. Mathematical model. Mathematical model of oil filtration problem in a piecewise inhomogeneous porous medium is reduced to the integration of a partial differential equation of parabolic type as shown below. The boundary conditions for the integration of equations are these formulas and then here is explained the symbols of given formulas above. The numerically solved problem, the following dimensionless variables are introduced. Later, for simplicity, the sign in the equation is omitted. Then, taking this into account, problem in dimensionless variables is rewritten as follows. For the numerical solution of the problem by the differential sweep method, the filtration region G with the outer boundary G is covered with, by the grid region. Differential difference equations are used to transit from one layer to another. Using differential sweep method, system of differential difference equation is solved. Here the coefficients of the left hand and right hand sweep are found as solutions to the following Cauchy problems. Numerical integration of the Cauchy problem is carried out by the Ruchkuta method using the normalization procedure of the sweep coefficients and the coefficient of this method. Based on the development mathematical model, the MATLAB program developed a software product called computer modeling of the filtration process of liquids in a non-homogeneous porous medium. The program includes blocks that include the filtration time of liquids, initial pressure, viscosity of the liquid, length of the layer in x, y coordinates, layer thickness, well flow rate, permeability coefficients of the fragmented medium. Based on the parameters that we entered in the program, When you press the button to calculate the indicators, the result will display imagine in 3D graphics and cut out and write the commercial result in the file result.txt. Here is the MATLAB software product interface window. You can estimate parameters of the oil fields and the system created by authors will calculate according to formulas above. Then you can see the result as this form of 3D graph. So this is the form of 3D graph of pressure distribution of the lower profile, and the second one is the 3D graph of the pressure distribution of upper profile. And then, as a conclusion, the developed mathematical software tool provides the calculation of basic indices of oil field development and the visualization of results of a computational experiment in a graphical form. The software tool provides numerical calculations in graphical visual form and can be used in design, analysis, and forecasting of oil field development. Thank you for your attention and goodbye.